Hello, my name is James Alderson, and this is another iteration of the devlog from my Thetis blockchain project. So today we're going to look at a few things that we've added to the project since the last time I checked in, which is almost a month ago at this point. Took a while to get to this point, and the reason why is because I tried a whole bunch of different communication methodologies between the two nodes, but I finally got there. I'm not a network guy overall, but I'm working on making a network, so we got that. We did the P2P Node network, and we're using TCP IP. Originally, I used UDP packets, trying to send UDP packets between the two nodes, and that seemed to work for the most part, but there was no callback to my server, and without callback, I can't be notified which node sent which thing to which other node and stuff like that. So because I couldn't figure out that there was no notification system implemented in that protocol, I had to switch to TCP IP, and that took a lot of new learning. Took a couple weeks of learning before I could get to this point. So a few other things that we added here that we'll look into in a while is that we also added compression and decompression to this whole blockchain situation, and we'll check that out too because it's important for how we're going to be sending and receiving the blockchain between nodes after transactions have occurred. So first things first, let's just try to do this command here. So this command to send the blockchain between nodes, we have to type send command. So we'll say send blocks. And as we can see here, the blocks have been sent successfully between the two nodes. Seems like it kind of got in the way of my thing here, but that's fine. If we come over here, the information was sent successfully. This was just still writing, I guess, as that occurred. But we can come to this end and we can see that message received, and this is the whole blockchain here being sent. And it looks just like jibber jabber. None of this really makes sense. It's just a bunch of fucking numbers and whatever, encrypted addresses, all that kind of stuff. But if we come down here and we see our blockchain here, we can see that actually what was sent, this here, number 46, that's this right here, this JSON format documentation here of all the blocks that have occurred. So this exists on your computer with the blockchain. At first it'll exist on the computer. My hypothetical plan here is that because blockchains could get huge if they exist on your computer over time, that eventually I might just host the blockchain at a server somewhere, and then everybody will just download. Instead of downloading copy, you'll just get communicate with a virtual machine. The virtual machine will give you a copy for usage sakes, and then you never store anything actually locally. But for now, the way that it works is that this blockchain is stored locally on every machine that's connected in a P2P node network. So we achieved that. We used TCP IP to send something between the two nodes, and we've got it successfully here, and we can look at that over here in my little diagram I made. And so what's happening here is that there's a P2P node. That's each one of these is a P2P node, but currently they're kind of segmented out. The server exists on one end, the client exists on the other end, but they both will be connected to one node once I compile them into the same program. You have your local wallet application that is attached to this P2P node here. And this P2P node contains both a TCP IP server and a TCP IP client. The server communicates with the client of the other nodes, and the client of our node communicates with the server of the other nodes. So right now there's two nodes, so it's just this tight little diagram here to explain everything. The web host, right now we're using my local host, but this web host will eventually be somewhere on the internet. I don't know where I'm going to do my web hosting yet. I haven't figured that part out, but I will be testing actually web hosting it in the weeks to come before we actually get to the full wallet application situation and buying and selling with PayPal and all that, which we'll talk about in a bit here. So let's just go through the whole process here. So this part, compression, decompression, it exists as a command, but the command hasn't been implemented into the whole process yet. We look at our P2P node, it will communicate to this server will then say, look for clients, and this client exists, so it's able to send down this thread here. What I will be doing is that I will compress and decompress the blockchain in this portion of the whole workflow. It'll be compressed by the server and decompressed by the client, and then same thing backwards. Compressed by the server, decompressed by the client. And the reason why we're going to do that is because I mentioned just earlier, if this blockchain exists on somebody's computer, after a while the blockchain will start to get huge. It'll start to be hundreds of gigabytes in size after hundreds of millions of transactions. If it did get to the point where there's hundreds of millions of transactions, then something would have to be done about that, because not everybody's computer is going to be able to just sit there with gigabytes upon gigabytes of space on their disk just being taken up by this blockchain. So if it does get some usage, that will be a primary objective of mine, to actually host the blockchain somewhere else, so the blockchain doesn't exist locally on people's computers, and they'll just communicate to it in a similar way that instead of loading it from your computer, it'll be loaded from a virtual computer. You'll do your transaction and it'll be put back onto your designated virtual computer. And that will be, in the long run, if this ever takes off the ground, I will put some time into actually making virtual machines and all this thing. So that's the whole idea of the TCP IP server, TCP IP client, kind of P2P node network here. P2P means peer-to-peer, by the way. TCP IP, I'm not exactly sure what TCP IP stands for, but I'm using the TCP IP protocol. That's why it took me almost 3 weeks to get to this point, because originally I was using UDP. I had to learn about a whole new network protocol and everything to be able to utilize TCP IP effectively and to do this properly, to send it between nodes. Okay, so that is this part of it. So now we can come back here, because we're going to look at another functionality that we've added to the blockchain here. So I'll move this guy up over here. We're just going to look at this one for now. So here we're going to say compress. And the reason we're going to say compress, file successfully compressed, file compressed. So what does that actually mean? Let's come over here, and we'll come up here to look at the blockchain, which is open here. I already have the blockchain open here, so we can look at this. So here's your blockchain. This is the same thing that I sent over here if I scroll up a little bit between nodes. But as you can see, that's already a lot of data. As bytes, I think this was 51,272 bytes, or about 51 megabytes. Which doesn't sound like a lot, but sending that packet between several different machines all the time is huge amount of network usage already. So how can we achieve a lesser amount of network usage and make this more efficient and cost effective? Especially when we're talking about cost on the computer, not just financial cost. So let's come back to our little documents folder here, and we'll look at here. Compressed blockchain. Well, that's a lot smaller, isn't it? Now this might just look like gibberish. Sorry. This might just look like gibberish. It all looks like gibberish, probably, if you have no real background in computer science at all, and encryption and compression. But this is actually the same file as this, but compressed. It has been compressed down so that the size of the file is now an encoded version of it that is way less in size. It's not as large, nowhere near as large. So let's look at the properties here of the blockchain, and we'll look at the properties here of this guy. Where that properties go. Here it is. Okay. So let's look at these two properties side by side. The size of this one is 23.7 kilobytes. And the size of this is 4.57 kilobytes. It takes up 24 on the disk because there's extra room for parity bits and stuff like that. Here it's 8, so there's actually 4 kilobytes worth of parity bits and stuff to say, hey, You know, if this bit goes wrong, flip the next bit, blah, 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 so that you can get the file back as intended. So, basically, what I did is I compressed this file down so that it would be a lot smaller, about, what is that, 26 times smaller than its original form. And this is actually what I'll send between the two nodes, is like in the final version of it, it'll send back this compressed version of it, and that will be decompressed on the other side. So we actually have that implemented too, decompression. So we come back here, and we did a compression event here. Let's try to say decompress. And we come up here and it says decompress, file decompressed successfully, file decompressed. It says that twice because it decompresses it, and then for redundancy's sake, like when I was testing this, I said file decompressed to make sure that, because it's reading it in, so it reads it in, it successfully does it, and then when it writes the file, it actually says file decompressed because the file was created. So now we can come back here, file decompressed, and we can see that that file didn't exist before, but now it does exist again. And we have this now on the blockchain. We have the blockchain back again, I should say. So that whole process will occur if we come back to our little diagram here. So when when our P2P node or peer-to-peer node wants to communicate with this other peer-to-peer node, so this is me and this is you, and I want to send you something, I'm going to actually, we'll do our transaction, right? And then I will send over a compressed version of the blockchain once the transaction has been validated. So I validate my version of the blockchain, and I send you the whole blockchain to your version with the new added transaction. As well, you will now receive, let's say I sent you some tokens, you will receive your tokens at the same time as receiving this blockchain. But everybody else is just going to receive the blockchain. So if I have 100 nodes or 1,000 nodes that are connected on the blockchain, they all receive a copy of this when that occurs. They'll receive this, but in compressed form, so they'll actually receive this is what they'll receive, and then they'll break that back down into this. So that's how this is going to work. I send compressed, they get decompressed so that they can get the valid information. This same blockchain is sent to everybody connected to the network anytime a transaction occurs or some action occurs that has been validated on the blockchain. A creation event of an ETS or another token, or of EBA, encrypted blockchain assets, all that stuff, that will be validated on the blockchain, and that's sent to everybody. So that's basically the gist of it from what we've added so far in the last about month since I made one of these videos, as I've added all this kind of interesting stuff to it. So we can look at our little diagram, another diagram I have here, and I made this a while ago, and like probably Devlog number 2. And we completed this localized wallet encryption and encrypted blockchain assets. We did the wallet application in an AES key for this encryption decryption. We did that a while ago, almost a month ago. Phase 2 starting, Thetis P2P Node network. So in theory we have this not done yet, but pretty close. We have it working in a simulated version between two nodes. And if you wanted to scale that up to several different nodes, it's basically just a matter of putting this onto the web so I can, you know, do more than 2 nodes, 3 nodes, whatever. I could do 3 nodes on my computer if I wanted to, but I'm just trying to be kind of energy preservant on my computer a little bit here. So the next steps we have to do is buying ETS tokens from the PayPal Holdings account and selling them to external accounts. That's going to be in the actual Thetis wallet application and the OAuth authentication layer. I might discard this part of it. I'm not sure yet, because authentication costs a lot of money. And if I want to keep this all relatively cheap, let's say, relatively cost effective, I don't know if I can do authentication for thousands of nodes, if that's where it gets to. Because if I do authentication, that would be costing me thousands of dollars. every month. And that means that I would have to charge these exorbitant network fees to people, where the whole idea of this is to be less, to take less money from people, to be more of an open and encompassing project compared to other blockchains, and not to, not to middleman people as much as these other blockchains do, but to try to provide this really safe and secure, but also have high liquidity in the market so people can trade, and also to avoid vulnerabilities and to avoid volatility in the market. There's a whole bunch of things. I will eventually write a white paper for all of this and put it out there. But there's a bunch of things I'm trying to tackle and conquer with this project that I didn't see on other blockchains. So, last thing here to look, well, let's just go over this one more time. I did this stuff over here. Wallet manager application. I don't really have anything here. Here's my... I did this a long time ago. I was working on this part of it right here. Right? I gotta make my wallet application now as well that will plug into this Thetis P2P Node network thing. And then I can start working on communicating with PayPal. I can make my PayPal account. I'm going to make a shell company essentially for that to operate PayPal through. Buying and selling the ETS tokens to the PayPal account, and then giving those to external accounts. I'll work on that. And then OAuth, maybe we'll do OAuth or Auth0 or something like that, but that part of it isn't entirely set in stone. I would like to do authentication. That was part of the idea, but I don't know if it's going to be cost effective. So, last thing to go through. This is just my little mock-up I made in PowerPoint to kind of go through what I'm planning the application to look like. So this is the first screen, your landing screen. Say Thetis right here. You can log in. You can create a wallet. So if you haven't created a wallet yet, you create a wallet. If you log in, you log in. Here's just your login, password, confirm password, whatever, no big deal. Here's the landing screen. So now I've logged in, and so the first thing you'll see is that you get to your landing screen, which is actually your balance screen. It's the same thing. And we'll say we have 1,000 ETS here. We can buy some more ETS. We can sell ETS. And this is the buy and sell to the PayPal. If we come back over here quickly, that's basically facilitating this part here. Buying ETS tokens from PayPal account, which holds USD and actually a real holdings account that has real money in it, and then selling tokens. So if I sell my tokens off, there's money sitting there for me to be able to sell it to sell it off and give money to my external accounts, to some other PayPal or to my bank account or something like that. So that's okay. That's just this page here, and then there's other tokens, which right now no other tokens exist, but other tokens can be created through this wallet application actually, and that'll be in the Create tab here. And those tokens will be here if you buy and sell them here. You can click on them, and that will open up this token. I click here, that opens up this token, and then I can, or when you click on it, it'll go to this page, the send screen, sorry. So you're sending. If you click on one, it'll automatically put it here, but I can type in a token address here if I want to. Receiving wallet is the wallet that you want to send it to, and then this will calculate a network fee for you. So there will be network fees, and I'm going to try to keep them to a minimum, because basically I don't necessarily want to make money on this. I'm just trying to provide a service, and if I need to, if I have to rent out virtual machines, and if I have to have servers out there and everything, then I'm going to have to pay for those services myself. So I'm going to have to charge a small fee to be able to uptake those, or keep up those services on my own, those networks and everything, which I'm creating my own network. This is my own network here, but it has to host somewhere on the web. So I have to have a domain. I have to pay for that domain. I have to host this somewhere. When you go up, you're going to communicate to the host, and so that's the sending page. And then the receiving page, here's a QR code. Don't know if this is actually gonna, this is just like hypothetical, but so say that you have this QR code, this will be your wallet here, and I could show somebody this, and they can take a picture on their phone or whatever if a phone version of this gets made. But anyways, receiving wallet, This will be your wallet here, and then network fee. Same thing. There's a small network fee if I want to send these tokens to other people, or if I want to receive tokens, because I need to keep the network going somehow. Nothing's free in this world. Okay. Sorry for coughing a lot. I had the flu just recently. Still getting the stuff out. Thetis. Oh, sorry, not Thetis. Sorry, this is my create page. Okay. And so Thetis, in a prior video, I showed off how to create an EBA, or an encrypted blockchain asset. So this is the create an EBA screen. I click on this one and I get this. I put my document here, which right now is only working for images, but it can easily be converted to be any kind of document, and I will work on that in the future. I say this will give me my contract name here, and then if I want a royalty on it, kind of like the way that NFTs work, anytime someone buys or sells my encrypted blockchain asset, this royalty will then be given back to me. So I can put a royalty if I want to, and I can just click create. So it'd be very simple to create EBAs through this process. Most of the stuff is done for you when you're creating an EBA, and in that way, and then you'll be able to buy or send these and receive these to people by putting the contract name in where the token name was. If I go back there for a second. So you are sending, you'd put your, instead of putting the token in here, like my token address, I'd put my EBA in there, and I say, okay, here's my EBA, send it to this guy. And then that will actually send him this file, which is encrypted. And then the only person that can open it is the guy that has the key, so that this guy will now have the key to be able to view the encrypted blockchain asset. Tokens, so here, this is a very simple way to make a token. You just upload an icon, you click the token thing, you upload an icon, you name your token, and you provide liquidity from your ETS tokens. So you, prior to this, you would get some ETS tokens, you'd go through this whole process here. I say, oh, okay, I want to buy some ETS tokens from the blockchain, right? From the wallet that, there's a creation wallet that will be there that everybody can buy and sell to, and it says, hey, I accepted this, I want this much. So this guy says, oh, I accepted $50 of USD into my PayPal holdings account. What is that worth? The ETS contract, which is Elastic Token Standard, that I wrote myself. I made this contract. It'll say, oh, okay, deposit this amount of ETS tokens into this account, and that whole thing will happen. And now I have some of those. So imagine I did that and I have 1,000 of them. I have 1,000 ETS tokens now, and I'm going to provide them as liquidity. So I make my token, I put in 1,000 here, which now means that I have 1,000 ETS worth of USD, which at the beginning that would probably be like $7 or something like that worth of ETS. And I put my token out there, and people can buy and sell the token, and when they buy and sell the token, it just goes from the liquidity pool and distributes out, like if they sell them, it distributes out some ETS to their account. And then they can further sell those ETS back to real USD and hopefully other reserve currencies, which I have a whole plan on that I don't know if I'm going to discuss it in this video, but originally it'll be USD, but the idea is to build up reserve currencies and all these different currencies to provide liquidity to people all around the world. So this will be the transaction history page. You click on history tab, and it's just going to show you what transactions have occurred that you've done. So every time you do a transaction, it comes into your transaction history. You can go and you can look at it here. So basically it's like a little mini blockchain explorer that you can, instead of having to dig through all of this looking for what you've done, you can just look at exactly what you've done. And lastly, the settings screen. So here's your settings screen. This will show your wallet address. This will be your name. This could be a real name or whatever. This will be your email address that's linked to the wallet address. And then when you click on this will reveal your private key so that you can look at your private key if you want to import it into another machine or something. You don't want to give away these private keys, just like any other blockchain. This private key is your identifier for the wallet, so you don't want to give that away to people. Payment information, this is where you'll set up your PayPal and your other bank accounts. So you'll click here and that'll set up you'll import a PayPal account or connect to that, and that'll connect to that through the API. And then where you want to deposit your money to, you'll set that all up inside the payment information tab. And then 2FA, two-factor authentication setup. Again, because I don't know if we're using OAuth or not, this might just be hypothetical. I don't know if this is actually going to be in the final product, but this is what I plan. I want there to be two-factor authentication so that nobody can get in to your wallet unless it's you. And there's several layers of security to make sure that it's only you getting in. So yeah, that's my little spiel here for today. I don't really have much more to talk about at the moment, because I've got this working here with the node network, at least for sending the blockchain between two nodes. I will start working on actually making this application now. So this application doesn't exist yet. This is just a mock-up. I'm just drawing it out, what I imagine it to look like and what I imagine it to feel like. And that will actually, all this, everything that's happening here, encryption, decryption, compression, decompression, all the transactions between the things, sending the blockchain between things, this is all going to be imported and transplanted into this app so that you don't actually see any of this. This is what's going on in the background, but there's a nice, comfortable UI that I've created here for people to just easily do their transactions, easily get their funds, send funds, whatever you want to do, and it's going to be super easy to use and super user-friendly while all the complex stuff is taken care of in the background. So that's it for today. That's my devlog of everything that I've added in the last 3 weeks or so, which I had the flu for some of that, so maybe it was like two and a half weeks of work to get to this point. And I just wanted to make a check-in that I got this working very recently and wanted to talk about it. Alright, that's it for today. Bye.